Hello Year 10. Today we are talking about the four quadrants, and that is referring to this diagram that you can see here. So we have discussed this in previous lesson, and what we learned was that when we measure angles in this type of diagram, we start here on the x-axis at 0 degrees. Okay, then we move in an anti-clockwise direction, meaning that this one at the top will be 90 degrees, 180 degrees across here on the left, and 270 degrees down the bottom, all the way around back to where we started would be 360 degrees. Okay, now we want to talk today about reference angles or related angles. If I measure an acute angle in this first quadrant, there is a relationship between that angle and other angles in the other three quadrants. Now the relationship goes like this. If I choose an acute angle in that first quadrant, I'm going to choose the angle 30 degrees. In the second quadrant, we call this the 180 minus theta quadrant. Now the theta is what we call that reference angle, the acute angle. So 180 minus my 30 would be a 150 degree angle all the way around to there, 150 degrees. Now what happens if I type in sine of 30 into my calculator? And what happens if I type in sine of 150? Well, let's have a look. So, sine of 30, that's equal to 0.5. Okay, let's try the next one. Sine of 150 is equal to 0.5 again. Okay, so you can see that those angles are related, and it doesn't just work for 30 degrees, it works for any acute angle. Sine of an acute angle in the first quadrant would be exactly the same thing as sine of 180 minus that acute angle, whatever that makes. Let's see what happens if we push the angle into the third quadrant down here. Now to find the angle in this quadrant, we would want to do 180 degrees plus the theta, because 180 degrees is to this line, and we want to add the theta on to bring it down into this quadrant. So the size of that angle would be 180 plus 30, which makes 210 degrees. Okay, that's all the way around to there, 210 degrees. What is sine of 210 degrees? Back to the calculator. Sine of 210 is, this time it's negative a half. Okay, so we still have the half, but now it is negative. Let's try our last quadrant. To find the angle in the fourth quadrant, we would do 360 degrees because we want to do the full revolution. And then we want to come back this 30 degrees that we've put in here. So all the way around to here would be 360 minus 30. So the 360 minus theta quadrant is what we call this. 360 minus 30 is 330 degrees. Sine of 330 degrees is minus a half again. Now I've just shown you one demonstration, but what we can see from this is that sine has the same, sine of 30 in all four quadrants has the same 0.5 that is showing up. It's just that in some quadrants it's positive and in other quadrants it is negative. Now, these letters that are written around the outside here, we have an A, S, T, and C. Now these letters are very important. The A stands for all. all. S stands for sine, T stands for tan, and C stands for cos. And what they are there to remind you is that in the first quadrant, the A quadrant, sine, cos, and tan of anything in that first quadrant will always be positive. So A is for all, everything is positive in that first quadrant. Going into the second quadrant, the S quadrant, sine is the only one of the three trigonometric functions that is positive in that quadrant. So sine of 150 is going to be positive, but all of the other ones, cos and tan, would be negative in that quadrant. In the third quadrant, only tan is positive, sine and cos would be negative. And in the fourth quadrant, the cos is positive, but the sine and tan would be negative. So to remember the A, S, T, and C, we have a little saying that is all stations to central. Okay, so you'll often hear people saying that, all stations to central, which is reminding you of the order A, S, T, and C as you go in an anti-clockwise direction around that circle. Okay, so we're going to practice this with the example that's down below. It says number 1 there, decide in which quadrant theta lies and state whether sine theta, cos theta, or tan theta are positive or negative. Okay, so the first one is 330 degrees. We actually just talked about this one. 330 degrees, I'm going to draw it on here in red, approximately down here, 330 degrees. Okay, it's more than 270, less than 360, somewhere in this quadrant. And we call that the fourth quadrant. So let's just write on here, first, second, third, and fourth quadrant, just so you make sure you get the numbering correct. So 330 degrees is in the fourth quadrant, which is called the C quadrant or the cos quadrant. Only cos will be positive. So that means if I want to know what sine of something in that quadrant would be, so sine of theta would be negative. Cos of something in that quadrant, it's the cos quadrant, will be positive, and tan of something in that quadrant would be negative. Remember, it's the cos quadrant, only cos is positive, the other two are negative. Part B is 195 degrees, so 180 is just here, so it's going to be a little bit beyond that. Doesn't have to be perfectly accurate, I'm just going to draw a little line in here. So about in there would be where 195 degrees would be. That is obviously in the third quadrant. So what is going to happen for sine of something in that quadrant, cos of something in that quadrant, and tan of something in that quadrant? Well, the third quadrant is known as the T quadrant or tan quadrant. Only tan is positive, the other two will be negative. Okay, let's move on to example number 2. Write the following using their reference angle. Reference angle, remember, refers to the corresponding acute angle. Okay, you'll see that the angles in this question here are all much larger than 90 degrees. So we want to find the corresponding acute angle to the one that is given to us. So the first one is sine of 320 degrees. Now you're not always going to have that lovely big all stations to central circle there to draw on. So what you will need to do is draw yourself a little one over on the side to help you work this out. Okay, so just a quick XY axis, circle around the top. Mine's even a bit wobbly. Don't worry about that too much. 320 degrees. Okay, remember you've got 0, 90, 180, 270. So 320 would be somewhere in this fourth quadrant. Okay, all the way around there is the 320. To find the reference angle, we want to find the acute angle. We want to find that part in there. So remember that this quadrant was called the 360 minus theta quadrant. What I can do is go 360 minus 320, and that will tell me the acute angle. 360 minus 320 makes 40 degrees, would be the size of that angle. So we also have to remember we have the ASTC that goes around the outside. So we're actually in the cos quadrant. So sine of 320 degrees is going to have the same size as sine of the reference angle or the acute angle, which is 40 degrees. But because it is in the cos quadrant, when I write it as an acute angle, I need to include a minus sign because I know that will give me a negative answer because it's in the cos quadrant. And that's it. This answer here is all we're after. We're just trying to write the same problem, sine of 320 degrees, as sine of an acute angle with the correct plus or minus sign in front of it. So let's try that again. Cos of 150 degrees. So again, draw your little all stations to central over the side. 115 degrees would be a little bit past the 90. It would be in here. 115, like that. Okay, so we want to find the reference angle or the acute angle. Now that's always the angle that goes to the horizontal. Okay, we never go to a vertical line. We always go to a horizontal line. So this line across here is where we find the acute angle too. So this is the 180 minus theta quadrant. 180 minus 115 is 65 degrees. So that means that cos of 115 is the same as cos of 65, but will it be positive or negative? Well, it's in the all stations, it's in the S quadrant, sine quadrant. Only sine is positive there, so cos needs to have a negative sign. One more of these to go. Part C. Find tan of 203 degrees. Draw your all stations to central diagram. 203 degrees would be more than the 180 line, somewhere in this third quadrant. So 203 would be around to there. We are trying to find the acute angle to the horizontal line, that one in there. So this is what we call the 180 degree plus theta quadrant. So what I need to do is take that 203 degrees, subtract off that 180 so that I can find that acute angle in there. So 203 minus 20, start again. 203 minus 180 gives me 23 degrees. Okay, so tan of 203 is the same as tan of 23. Now I need to check if it's positive or negative. All stations to central. We are in the tan quadrant, so tan of something in that quadrant will stay positive. I don't need to put a minus sign on that answer. That's finished. Okay, now I've included one extra question here because I thought it would be important to help you with question 13 in your exercise down here. So here's your question 13, and I'm going to do question 13D. So the question says to give the exact value of sine 240 degrees. Now, you learnt about exact values a few lessons ago now. Hopefully you remember these triangles. Okay, I've drawn one of them over here. There was a second one as well, but I've drawn the one that's going to help us with this question. So we start the question very similarly to what we were doing in question 2. We want to find the reference angle, the acute angle. So let's draw our diagram. 240 degrees would be more than 180 but less than 270. We're going to be in the third quadrant again. So 240 degrees goes around to there. Like always, we want to find the acute angle to the horizontal line. And we would find that by going 240 minus 180, which would give us 60 degrees. So, like we did in question 2, that is telling us that sine of 240 is the same as sine of 60, but we've got to check the sign. Is it positive or negative? So all stations to central, it's in the tan quadrant, which means that sine of 60 would need to be negative. Put the negative sign in. Okay, we did that in question 2. The extra step here is to find the exact value of sine 60 by using this triangle over here that I've drawn for you. Now, sine of 60, remember using SOHCAHTOA, sine is opposite over hypotenuse. So in this triangle, for 60 degrees, the opposite is the root 3 and the hypotenuse is the 2. So that means that sine of 60 is root 3 over 2, and I have got the minus sign that was at the front of that as well. Okay, so we want that extra step where we find the exact value from our triangle. Okay, so that will help you with question 13.